Okay, this video is going to be called GPS, flat plane required. Okay, I'm going to go through, I know I've made some videos before this on GPS. This one's going to be more specifically to do with how a flat plane is required, or how they have to start with a flat plane. So what I'm showing here on screen is the Globe's claim concerning GPS. Now, I know how it's done. I know how they, well, when I say is, I know what they claim. Now, I show how it could be done within that paradigm, but it involves things that, let's just say, they don't straight out tell the public about, right? Not what I mean is that they kind of, not that they're hiding the information, they're just not divulging it, right? And this involves their own heliocentric GPS claims. Okay, here you have the globe in the center. Here you have 4 satellites, the blue, the green, the red, and the purple satellite. Here you have their consistent orbital path around their globe. Okay, now just to show, the distance is an average of 12,550 miles. That's the claim. So all GPS satellites have an average distance of 12,550 miles from the globe surface. I'm pretty sure it's from the globe surface they're talking about, not from its center point. But it doesn't matter, right? Either way, it wouldn't change anything. At night show here wouldn't change due to that. So just to show, here is what they claim, right? So the satellite intersects the globe, right? The satellite uses its distance from the receiver, right, as a radius to create another sphere, and that sphere intersects the globe. So you have 4 satellites intersecting the globe here, right? And but over here then they show kind of a satellite where it's more nearly in the center. So it's not, so their claimed intersection points, spherical caps or whatever, they're not circles on a globe. These spherical caps, they actually don't really, when you look into it, they don't match a distance to a receiver. They match a distance to a subpoint, right? Now, why I'm going into this is, it was claimed by our opposition in my previous videos that I was strawmanning the globe when I was claiming that the satellite, within the claims of satellites, they're using for a GPS, they're using subpoints, and they're using angles, and they're using azimuth, and which is compass bearings. And all our opposition, they all claimed, no, there's no GPS, there's no compasses in GPS, doesn't know anything about angles, there's no subpoints used. This is what they've even made videos claiming this, right? These idiots. And so I was told I was strawmanning the globe, even though I knew what I was talking about. These people tried to tell me I was strawmanning the globe. And it's not that they were lying. What I mean is, from their point of view, is that they just don't know what they're talking about. It's that simple. They don't understand this. They don't understand the whole situation. So from their point of view, it's just like the generic Wikipedia search. A receiver finds its position on the surface of their globe via just knowing the distance to a claimed satellite, and that's it, and that's all that happens. This is their claim, right? Now, I'm going to show here how it can work on a globe, but it needs more than what they're claiming, right? This is how it can work, right? All of these claimed satellites, they all move, right, around the orbital path of their globe, right? And as they move, as you can see there, watch that little, right? As this is moving, the subpoint is moving, right? So here you have the subpoint for this blue satellite. I'll use this one, right? Now, that changing figure there, that is a changing distance between the receiver and the claimed satellite, right? So now it's at present 14,536 miles, right? But this satellite is always a constant distance from this point, which is its subpoint, of 12,550 miles, right? So what they're doing within that claim is they're claiming first, right? Within, this is the only way it can, this is not even the proper official claim. What I mean by that is this is the only way it can work. It could work mathematically on a globe, But this is after the fact, and I'll get into what that is, what I'm talking about there in a few minutes. So this here, this gives them two lengths. So they have this length, which is a distance to the satellite, right, within their paradigm, and they will use the fraudulent two-way speed of light calculation. That's another video I'll have to make on how much of a joke that is. The two-way speed of light calculation to calculate that distance. So they're going to have a calculated distance, not a measurement, just a calculated distance. And the thing about that two-way speed of light calculation, why it's so popular with heliocentrism, is that's the very thing that gives them these massive distances that they need, right? We don't have these massive distances in light years in reality, but that gives them their massive heliocentric distances. A lot of people don't realize is that what came out very soon after the claimed distance to the sun was the claimed speed of light, right? So isn't that a bit funny how they knew a distance to the sun and then they knew the speed of light sometime after that, which is a load of rubbish. There was no measurement of the one-way speed of light. It's only a two-way calculation and it's fraudulent. And I will show that in another video. In spades, like I'll show it in spades, how much of a load of rubbish it is. But for this here now, we're going to just use it just to appease them, okay? So the distance between the receiver and the satellite is 14,231 miles, and the distance between the subpoint and the satellite is always 12,550. So that gives them two side lengths, right? All they need now is a third side length, right? Which they can get, and they can gain the angles because they know the length of this and the length of this. So the length of this line here is 14,231, and the length of this one is 12,550. So that tells them, and they're getting, they're going to use these, right, and then connect them up via that, right? So they've just connected up them via a cord, right? That's what they've done. And then based on the length of the cord, they can then calculate the amount of arc, right, between these two positions. So the receiver then knows its distance in arc length to the subpoint. Remember, subpoint is something our opposition claimed, and they even made videos about it, was something that GPS does not use and is only a straw man, right? Now, that means they don't even know about this. I figured this out myself. I didn't need anything to figure it out. That's the only way they could make it work mathematically. But as I said, this is after the fact. As I said, I'll get into that in a minute, what the fact is, right? So this chord line allows them to, because they're using a consistent globe of radius 3959 miles all around, not an oblate spheroid, right? And they're using, right, they can make calculations after that for an oblate spheroid if they want within their calculations, because that's all they have. But they have to use a perfect sphere because they're using a perfect orbital path for this. Because if this orbital path, if this line here is a changing line, right, that will still be usable once they know the change based off of how much oblateness the globe will have, right? I have to just add in these things because I know the ballers are going to come at me as if that's some kind of something important. It's not. And the oblateness, just so you know, the oblate spheroid claim comes from a pre-assumption. The pre-assumption that the globe that a perfect sphere is rotating for such a length of time that it becomes oblate at its equator, right, due to centrifugal force. So there is no calculation. Like if they're going to calculate anything for the globe, they have to use the globe as a perfect sphere, right? It has to be a perfect sphere, right? If they're going to use it, they have to use it as a perfect sphere. They can then after calculate for an oblate spheroid, but they must start out with a perfect, well, they don't start with a perfect sphere, they start with a flat plane, but that's what we're going to go on to next. But after they get the sphere, they then oblate it. So that's what they do. So start with flat Earth, right? Start with a flat plane, flat Earth, all the time. Back calculate to a globe, then back calculate to an oblate spheroid. The oblate spheroid is purely based off of, and the bulk of the oblate spheroid is the latitude and longitude grid on the globe, because it can't work with an oblate spheroid. It'd be like a jumper that's too small for you. what's going to happen, or that it's not fitting right. So you pull it down, it won't go all the way down to your waist because your rib cage is too wide. You know, think like that, right? It's that ridiculous, right? So the latitude and longitude grid won't fit on it because it's a very specific grid that's measured over a flat plane. And there's specific spacing between those latitude lines, and that spacing would have to change. Now, there is a claim that that spacing changes within their paradigm. It's mad I have to go into so many details, but I have to. But that's only a claim that they have to, an after claim they have to make after they have pre-assumed several different things and ended up in crazy land, right? So that's what that's about. There is no change in celestial navigation. There's no change to the distances between latitude lines. That's complete rubbish. There's no change. If that was the case, you'd be using a sextant. You'd have to, using a sextant, then it wouldn't work correctly near the equator. Everything would have to go off. Everything would be off. Everything would be out. Do you know what I mean? If you think of it like that, you couldn't get, how are you going to get your latitude to Polaris if 1 nautical mile is not 1.1508 statute miles? How are you going to do it? Because that's what they'd have to claim. It's complete nonsense. But I have to throw that in just so people know that I do know all these back stories and I know all the nonsense. I know more than that, but it's not important, right? It's not outward important right now. But as I said, if I don't put it in, this nonsense is going to end up in the comments as if it's some kind of rebuttal, right? So here you have that chord length there will change as the position, right, the distance to the receiver changes, right? So the chord length will then change, right? So, but that they get the chord length from pre-assuming these two things. But the problem is they need to have, right, our opposition will say they just get the coordinates of the satellite, whatever the bloody hell that means, and the distance to it. But that doesn't mean anything because the coordinates of the satellite is out in heliocentric outer space, 12,550 miles away from the Earth's surface. So that's nonsense, right? This is the coordinates that they need, and this is what I'm showing. This is how mathematically it could only work. This is the only way it could mathematically work on a globe after you start with a flat plane, which I'm going to get to. So this is how they make it work on their globe, right? This is how they make it work mathematically. This is how they get the arc length to the subpoint, the very thing that it was claimed I was strawmanning these fools with, right? As the same way as they've claimed that there's no angles or azimuth used. So let's just say it did get its distance via an arc length to this point, right? What does that mean to the receiver? It still doesn't know where it is, right? Even if it calculates this and an arc length, it still doesn't know where this point is in relation to this. It only has a distance and arc. It doesn't know the azimuth. So it would need the azimuth of the satellite, would it not? It would need azimuth, which is a secondary flat plane, right? The thing about it is this. They're starting off with an angle, right? And this is the official claim, and they're using azimuth. They're using azimuth and angles, right? I'm just going to show. Here, right? We start off here, right? These four spheres intersecting this sphere here, right? And then we go on to the next diagram. It's showing 3 circles around 3 satellites. Then we go on to the next diagram. And all of these lines, right, from the satellite are not meeting at the receiver here. That's what's claimed, that's what the borders think is happening. So there's a distance to these satellites from the receiver, and this distance is what creates these circles. Well, they're not circles, they'll be spherical caps over here, right? But here they're showing something completely different. They're showing 4 circles on a flat plane. They're showing actual circles, not spherical caps, on a flat plane, because circles are flat, right? And they're showing them as if they're created from it with a radius that's a distance between the receiver and the subpoint, right? So straight away, the story is changing from this. From this over here, right? It's changing to this. Those lines are supposed to be meeting here. These subpoints are supposed to be not being used according to our opposition. No, don't use them at all. That's a straw man, they told me. It's a straw man to say that there's angles, and it's a straw man to say that they're using, that the receiver uses angles, and a straw man to say that it uses tangent planes. It's a straw man to say that it's using azimuths. But here we have it, right? All GPS receivers have what's known as a microsensor compass in them, every one of them, and it uses the magnetic field of the Earth. It reads the magnetic field, microsensor compasses, and it isn't affected like a magnetic compass is. It's more done digitally. I don't know the full details of it. I know a bit about it, but I'm not going to go talking about it because I don't know enough about the microsensor compass to give a lecture on it. But I know that it exists, and I know it uses that. It's when it's pointing north. That's north magnetic. That's what it's pointing to, right? North, using the magnetic field. So it's using azimuth, right? And then you have the mask angle. It has to, there's the elevation of the satellite. It knows it is at 45 degrees. It knows it's not within the mask angle. And that means that it requires a massive plane of reference because its elevation is above a point right below it, right? So yes, I'm going to make this a bit bigger. So yes, the receiver is using angles and azimuth. So it's using a flat plane 2 different times. Now, if you just take a look at this line here, right, it comes to the satellite, what is that? What does that remind you of? That's this line, right? I'll try and hit. That's this line from this point here. Because what they've got going on is, right, move this out here. In reality, that's what's happening. So, excuse me. So in reality, that's what's happening. It has an angle to a satellite, and there's a secondary line, I'm going to get that actually, that comes down to there, right? That's what's happening in reality, not this nonsense up here. That nonsense there is not happening. But more specifically, what's happening in reality is this. The two-way speed of light calculation, right, is based off of making things be at massive distances. Now, it works on small distances, but when we use it with the heliocentric paradigm, it projects things out to be at massive distances that they're not at, right? That we don't know if they are or not, but the point is that it's using these massive distances. The two-way speed of light calculation allows them to send this satellite off out there, but in reality, what's actually happening, right, within that claim, and this is why they have to show angles and azimuth, in reality, you have this kind of thing happening, right? That's what's happening in reality. I know that's not exactly a right angle here, but just to show. Now, in reality, that's what's happening. There isn't this big, massive distance, right? Well, actually, right, I'm going to do this different. I'm going to do it on, right? In reality, this is what's happening, right? You have that, and then that. If I could get the thing to stick on, right? That's what's happening in reality, right? Within that paradigm, when they want that within their claim, that's what is actually happening. That's how they have to start their claim. Because their claim always starts from a flat plane through the center of their paradigm. That's where it starts. Now, the thing about this is that angle is exactly the same, right? If this height here, right, is kept constant, let's say this is the height and it's kept constant. So let's just say it's a balloon or something. There's a constant height above the surface of Earth, right? Then that angle will be exactly the same as if it's this far away and at an angle above this point. Do you understand what I mean? Right? They're using these two lines as constants, but these two lines, this line here is a constant. They don't need this other constant. They don't need this other one. They only just, what I mean is they don't need all this nonsense. This is after the fact. This is what's happening, right? Before they get to this nonsense we have here on screen, they have to, first of all, start with this, right? This is their starting point, and it starts from this flat plane at the center of their globe. That's where it starts from, right? Now, I'm going to show that, right? I hope I'm not confusing people here, but it's just, I have to show it. I know it's a bit tricky. So there's a constant distance they're using, right, that they're claiming is between their surface and the orbital path of the satellite, right? But the constant distance is actually just an elevation above a flat plane, right, for that receiver. So if this line here, if this line here got closer then then the angle would be more severe. If it got further, right, for let's just say that's a balloon or airplane, anything, right, then the angle will be less severe, right? That's all it is. There's none of this happening. This is calculations after the fact. None of the ballers could do this. Not one of them could do this. Right now, I figured this out myself because I wanted to make sure that I was being as honest as possible. And I wanted to make sure that I was shown how it could mathematically work on the globe if it can. And even this I might even have to renege on if I look into it a bit further. There might be something I'm missing here, right? But I'm not sure if I am. I think I think this is pretty much mathematically doable. Once you pre-assume a flat plane first and a few other things, right? It is mathematically doable, but you have to start with a flat plane. This is the problem, right? But as I said, this is doable because they know these two side lengths, right? Or they can pre-assume these two. Like mathematically, you can pre-assume this length and this length. This length here is coming from a calculation based off of the two-way speed of light claim, and this one here, this one here is from a two-way speed of light claim, and this one here is from a constant distance between the surface and the claimed orbital path. So yeah, you could totally figure out the angles then if you needed them between there, but you don't, because you know the two side lengths. And you know based off of this length here that you've calculated, you know the angle that it would have to be at in comparison to this. In comparison to this sub point here. But as I said, they said they don't use sub points. They said they don't use angles. They said they don't use azimuths. So it would still need, right, if that was like a circle or a spherical cap on the top of the globe, the receiver would still need the azimuth, because that's not going to tell it where on that circle the sub point is. So it has a distance to the edge of a spherical cap. Sorry, not a circle, edge of a spherical cap, but it doesn't have it doesn't have the azimuth, the compass bearing. So it still needs the compass bearing, no matter what, which requires another flat plane. So they can't do any of this without a flat plane. It just can't be done. So just to show, right? So this is what they're actually starting at. This is it. This is the surface of Earth here, right? But they're placing you and the receiver and this up to the satellite. This is basically the satellite. They're trying to say, right, is the satellite up here? But it's actually this angle here, right, is what it is. Not this plane here. It's starting here at the center. This is reality, and this is reality here. But they're pretending they're putting a sphere around it and placing it up here. Or you could say this is, you know what I mean? That's what they're doing. This is the flat plane we're starting with. Then they're putting another flat plane here. And for every sub point for the receiver and all 4 sub points, they're going to need 5 flat planes on the surface of the globe. That's how ridiculous it is. So they have a flat plane at the center and a flat plane here. So I'm just going to move on just to show. Right, here it is again, the ECEF point, right? Flat tangent plane, right? Why are they using tangent planes? Why are they using those tangent planes? Because in reality, they're dealing with a plane to start off with. So they can't deny the flat plane. They can't deny it. Afterwards, they can do calculations like I did that don't mean anything, because you must start with the flat plane. They must address flat because they have to use 90 degrees. They have to use right angle triangles. This is why they have to use flat. They have no choice. The Earth is not a globe, so they must treat it as what it is, flat and stationary. So just to show more, here we are again, that's a 90-degree angle. That can't be touching the surface of a globe because it's not going to be 90 degrees. This is a curved line, that's a straight line. So that's obviously incorrect. What they're actually pre-assuming there is a tangent. That's what they're actually doing, pre-assuming a tangent plane. Right, 1 second now. And here's what's actually happening. There's the receiver, right, here. There's the X and Y, there's the Z, and there's the altitude, right, or elevation and azimuth to the claimed satellite. So that's what they're actually doing. And they're just putting a globe around it and doing back calculations like I showed you. Calculations none of the ballers seem to be able to do. They don't use sub points, they don't use angles, they don't use azimuth. You know what I mean? All these things, they all denied all of them. They said I was straw manning them. This is what they said. Now, will any of them come back? Will they come back and force to say we were wrong? You weren't straw manning us, we were wrong. Will they say no? They won't. They won't say any of that. They'll just continue on as if nothing happened. That's what they'll do, right? Here you have right angle triangle. That's what's going on there, because in reality, that's what they're using, right angle triangle. In the video I made just before this on how GPS actually works, I could make this process work on a flat plane. I could make the process I showed work on a flat plane. The process I showed is better than this, right? The process I talk about is better than this. So if they're not using the process I talk about, they should be using it, right? Now, but I could make this work. I could make this process work. It's a bit more complicated, slightly, but I could make it work. But only on a flat plane. I can't make these things work on a globe until after I've used the flat plane. Then I can mathematically make these things work on a globe. Then I can mathematically make it work on an oblate spheroid. I can make that stuff happen mathematically after the fact, but I can't program a receiver to do those things, right? I can't get a receiver to do what I need it to do from a cold start without using a flat plane. It won't find its own location, it won't be able to do it. It requires a flat plane of reference, right? Just to show a bit more, here is Walter Bislin's calculator, right? Or Walter Bislin's site, right? What you have here is, this here is actually the center of the globe. That's what you have here, right? They're just hijacking the celestial dome model, right? That's all they're doing. And they're messing around, right? This is Walter Bislin proving that they need a flat plane for everything they do, right? Right? Latitude, right? There's the latitude, right? Longitude, altitude. So I'm just going to go to latitude again, right? See the way, watch the globe. See the way when it gets to 0, right there, it starts going down the way. Down the way is not down the way is not altitude. Look, watch it, right? 0, right? It gets to, that would be 0 for angle. If that was in, I'm just going to stop it there. If I was here with a marine sextant at sea using this visible sea horizon in Polaris, then I'm going to get 0 degrees to Polaris, because as far as I'm concerned, for me, Polaris has appeared to drop towards my horizon, which is somewhere out here, right? But when it comes to the globe, when I travel past the equator, my elevation angle becomes what? A depression angle? Do you know what I mean? This is the stupid thing about it. But this is what Walter Bislin has shown, how they've hijacked the flat plane and they hijacked the celestial dome model, and they just put 2 celestial domes, one underneath the other, and called it a globe. Now, I know I already showed where their radius and everything came from, but the point I'm making is, is that that's all that's going on here. This here, they're presuming, is the center of the globe. No, this is just the surface of reality. So this is the x coordinates on a globe, right? Yet it's moving on the flat plane too, right? And y coordinates on the globe, right? And you have z coordinates, right? Which is, see what it's doing? It's crazy, right? Z coordinates. See the way, watch the flat out. What is going on there, right? But that's the only way he can show it, and show it happening on a globe. Then you have x coordinates on a flat earth, right? Y coordinates on a flat earth. And I don't know, this is a straw man situation I'm sure he has set up, so there's going to be problems in here that are not addressing reality that I'm sure Walter Bislin put in there on purpose, as he always does, because his whole website is a straw man. And Zenith on a flat earth. Like, hey, what is going on there? What's that? What is that? It's going down, water, right? It's nonsense, right? But here you go. This is Walter Bislin. This is his calculator showing that he requires a flat plane, because all this stuff that's happening in the center here, that's actually just happening on the surface of Earth. That's all it is. That is what's happening here. There's no mystery to it. They're just taking everything that's happening on the surface and they're placing it at their center. But they're going one better than that, right? And I'll show. This is the celestial dome. As I said before, this just involves a protractor. It's just making a big protractor out of the sky, right? So here you are, right? Here is the protractor, right? That is just an orthographic way of depicting perspective. That's all. It's perspective placed into orthographic view. That's the only way they can correctly, or the best way they can do it. You can do it with triangles, but that's the best way, right? Like this, right? That doesn't make the sky curved. It doesn't mean we're on a curved surface. This is just the protractor that has a horizontal baseline. That's what that is. I'll show a bit more. Right, here we are again, observer. Right, the model below represents the apparent path of the sun across the sky on March 21st, which is the equinox, as seen by an observer on Earth. Right, the apparent path, right, of the sun, right, is it comes up, right, and goes over and down. Right, that's the apparent path of the sun. It's purely, and this is how they can show it in perspective here. Right, I'm just going to move on. Here you have the celestial dome around the globe, right? What's actually happening here is at the vernal equinox, the equatorial plane of the globe is at 0 degrees. So there's no tilt, right? So all of astronomy and every single time in celestial navigation, right, and in astronomy that they're doing anything, they pre-assume that they're at the center of a globe and that it's equinox, vernal equinox, which means there is no tilt to the globe. And they're using altitude and azimuth, right, and right ascension and declination, right? That's what they're using. But the thing is that at equinox, the equatorial plane of the globe extends out into the celestial plane, which means they're dealing with all the time for everything they do in astronomy and celestial navigation. And if they're using celestial navigation with aerospace, everything, they're pre-assuming that they're dealing with a massive flat stationary plane. That's another thing. In celestial navigation and astronomy, they're pre-assuming that the sky is moving and you're stationary. And they're placing you at the center of a globe at vernal equinox, where the equatorial plane extends out beyond into the celestial plane, which means you have a massive flat stationary plane. Now, I know this is not GPS. That's not my point. I know this is the celestials. But GPS is they're doing the same thing with GPS. They're using altitude and azimuth for GPS, where they're using, as opposed to right ascension and declination for the celestials. Right? I'm just going to go on here a sec. Right ascension and declination. Right ascension and declination are the celestial equivalents of longitude and latitude, respectively. Right? Right ascension, distance eastward along the equator. Declination, angle with respect to the equator. So this is all, like, so right, the only, like, right ascension and declination, right, it's basically altitude and azimuth. That's basically what it is, right? But here, vernal equinox, 0 degrees right ascension, which means there's no tilt. So they're not dealing with a tilt. This is exactly the same as what they're dealing with, sorry, here it is. That's exactly the same as what they're doing with claim GPS, where they're dealing with altitude and azimuth. Flat plane, always a flat plane, because they are measuring flat plane distances to the sub point of the satellite. They're not doing what I was showing earlier. I'll just show it there before I carry on. They're not doing this, right? They're not using any of this. They're using this, right? They're not doing this, but that is how I showed is how it can be calculated after the fact, because you first need this line, right? This line here. I'm just going to show you. You first need this line, right? That's the angle of their equatorial plane, right? That's the first thing they need, and that gives them their sub point, right? But they need this, and they also need, so that's the altitude and elevation and azimuth. That's the first thing they need. They need those two things to get this point. For this point here, they need those two. So the receiver is not here, it's down here. The sub point is not here, it's down here. That's the receiver, that's the sub point. So in this paradigm, with how they're claiming it works, this can work, but only on a flat plane. You can mathematically add in globe and then oblate spheroid after that, but none of it can happen without the flat plane, because it requires the angle right here, because it needs to know its mask angle, the angle, which is going to be a right angle triangle because it's an elevation angle, elevation 45 degrees, and azimuth, right? It requires azimuth. Compass bearing, as is shown here, azimuth, right? They're showing the azimuth. That's this is what's known as the horizontal coordinate system. It's what's used, right? It's the basis for right ascension and declination, and for the celestial dome model, right? So they're not doing what they're saying they're doing. They're always using a flat plane. You see, right? Here it is again, right? Here you have claimed to be the Earth, right? But no, this is the flat plane they're using, not this ball. It's a flat plane that starts in here. There is no ball, right? You need a flat plane. They're using altitude and azimuth. So it comes down to this, right? Does the flat Earth need a globe? No. Does the globe need a flat Earth? Yes. So we don't need the globe at all. But the globe and those who believe in it need us and what we are saying is reality, saying and showing and proving to be reality. So we don't need ye and all for anything. Ye need us. Ye need to hijack the reality that we're pointing out to you to mathematically create the globe that you believe you're standing on. And then when you want to go and prove anything to do with your globe, to me or anyone else on my side, you have to go straight to the flat plane that you need to start making measurements off of, to then calculate them, back calculate them into a globe. See, the thing about it is this. Let me just see. Right. This is where it started off. Let me just point out something here. They have this Mercator map, right, which gives them latitude and longitude, but in the X and Y, right, because GPS uses X, Y, Z, right, but it converts the latitude and longitude. So all the horizontal lines here are latitude. All the vertical lines are longitude, right? But there's a problem there. See, Australia doesn't have this amount of longitude lines through it. Between Perth and Newcastle, north of Sydney, on the 32nd degree parallel, there's only 2 hours of correct local time. Across America, which is the same exact distance from South Carolina to Southern California, across the 32nd parallel to Long Beach, right? That's 2 corresponding parallels. There is 3 hours of correct local time. There's always 3 hours of correct local time between those 2 locations across that same parallel, and always only 2 across the same parallel, the corresponding parallel south across Australia. The only way that's possible is for those longitude lines to be diverging. Now, what they've done is they've hijacked flat plane measurements to Polaris, right, which gave us the latitude and longitude grid. They placed it around a globe like this, right, and they've then projected the globe out from a central point with divergent light, still source of light, divergent light projected out into a cylinder that they then roll out. So then they can turn the latitude and longitude grid that's based off of a globe, right, and place it onto a flat map with using X and Y's, right, the XY system. And they can get Z then, which is elevation, right, from that. They can add to that, I should say. Just like with latitude and longitude, you can add Z to that, or you can add elevation to that. It's because X and Y and latitude and longitude are 2-dimensional. Once you add in the Z or the elevation, you're making 3 dimensions. But the whole point of what they're doing is they're using the flat plane, but keeping the coordinates to fit a globe. That's what they're doing, right? But this is all after they've hijacked the hell out of reality, and we've reached this point. What's funny here is the source of light, the projection, is divergent light projects a globe into a flat plane, right? But their globe comes from the claim that light that's almost parallel, right? Now, I've debunked this in the past, but almost parallel, right, gives them the shadows we see in reality. Well, that's nonsense, because we get the exact same shadows from the full moon, right? You can get the exact same shadows almost from a streetlight. So it's complete nonsense. But that's been their claim. But I find it funny that their source of light at the center of their globe projects out the globe into a flat plane. So they're basically saying, well, if you use divergent light, you know what I mean, you're going to see basically divergent light. And if you look at these, what they're showing is if they're showing shadows here, then that light would be proving the Earth as a flat plane because it's divergent, right? But within their paradigm, they had to claim that there's almost parallel light rays, and they had to do that. Eratosthenes was claimed to have had to have done that by claiming that there's a big sun that's far away, right? Bringing in angular sizes into it, something that's not part of our globe math. The whole thing is a complete joke. I'm going through so many things here. I'm literally going through a month of what would be videos here to describe what's actually happening. The amount of hijacking and back engineering that's going on to give you the impression that GPS is somehow a globe thing, when it's not. It's purely flat Earth based, just like celestial navigation, just like astronomy, just like aerospace. Everything is flat Earth. Every single thing they do is flat Earth. They have to start with reality, which is a flat plane, right? That's why they're not. They're not. Let me just show. Oh, sorry. Second one. They're not using this. I can make this work mathematically, but only after the fact. I can't create the latitude and longitude grid based off of measurements of me when I'm standing on a globe. I can't do that. I can't create those right angle triangles. I can't do it. It can't be done. I can't create the latitude and longitude grid that they needed to hijack and make all the south ends. I'm just going to show what just so you can see it. Where's work up, isn't it? Is this him? No, sorry, he's up here somewhere. Right. All they did was all the south ends of the latitude and longitude grid, or of the longitude lines, sorry, which was brought in underneath to meet, and that's what gave them their radius. That's why they have this distance here and here. That's based off of this, right? This distance here. That's the same as this distance here. This little red line here is the same as more or less as this distance here, right? Because they just brought these longitude lines around underneath to meet, right? Mathematically then, that creates a radius. When you switch from nautical to statuate, that creates a radius. But this all started here. You can't create this grid here, this grid we use in reality. You cannot create that on this surface, on this three-dimensional surface. It's a two-dimensional grid. It can't be measured. It can't be shown to work. You can't get it because you need right-angled triangles. You need elevation angles. It can't be done on this surface. It can only be done here. And that's why they must place everything at the center of their globe, because they need to hijack what's going on in reality and mathematically tell you you're living on a globe. But then what happens is they must come back at you with a flat map, right, that's based off of a globe projection, a globe that was back engineered from flat Earth elevations, angles, but place the longitude lines in such a way that they fit a globe. And that's all that's going on here. So the GPS system is using this, right? They claim to be using this system, the Mercator map. Now, I don't actually think it's really properly using that, but the point is it's claimed to be using the XY grid here, which will be converted back to globe latitude and longitude, right? That's what they're claiming. But yet they still have to do everything from their center point. Everything is happening from their center point. This line here, if that was going to a claimed satellite, then that's the line they're using. That's actually just on the surface of Earth. That they're just measuring off of the surface of Earth. Here. That's actually what that line is. That same line is just this green line here. That's all it is. So when the border said that I was strawmanning them when I said they need subpoints, I wasn't. When they said that they don't use angles, they do. That wasn't another strawman. When I said that they use azimuth, that wasn't a strawman either. They do. The receiver uses subpoints, it uses angles, and it uses azimuth, because that's the only way it can do what it needs to do. You can mathematically turn it into a globe afterwards, if that's what you want to do. But that doesn't mean anything to me, because I deal with reality. Right? Basically, we're after pulling apart. We've pulled apart their whole magic trick. That's what's after happening. And we're showing an audience their magic trick. And they're trying to stop us showing the audience their magic trick by putting big black blankets up in front of us and jumping in our way and trying to start arguments with us over stupid stuff. And they're doing everything they can to stop us from showing the world, right, what's behind that black blanket. That's what they're doing. We're trying to show the world what's actually happening. And we have these people who don't even know what they're talking about. I know they weren't even lying. They just didn't know what they're talking about. You have whoever, Wally, Blue Marble Science, all these people. They just didn't know what they're talking about. None of them know what they're talking about. Yet they're going to sit there online and start telling people, giving people information as if they're some kind of an authority. They couldn't work out. They weren't able to work out this. Sorry. Well, oh yeah, the next one. They weren't able to work out this, right? They weren't able to work this out. Right? This line, and this. They couldn't even work that much out. I could do that. I did that easy. They couldn't do that. They didn't, because they had to deny the sub point, the very thing that would allow it to happen mathematically on a globe. They had to deny it because they're idiots. But yet they want to get in your way, right? These bozos want to get in your way from telling the world or showing the world what's really going on, and they want to turn around then after getting in your way and speak to the person who would have liked to hear the information you have to give, and then they want to talk to the person as if they are some kind of an authority. They're not authorities on anything. They're bozos and they're idiots. And the sooner that the public realises that these people that are being put out in front of them are bozos and idiots, the better. Because that's what's happening. Because these idiots are getting in your way from relaying the information you have to give, which is truth, to the earth or to the world. They're getting in your way, and then after they've gotten in your way, they're trying to talk to the person as if they're an authority on something. They couldn't even work this out. Look, they couldn't even work that out. Even I could work that out. That took me no time. Like, what's going on? Right, this is this. Right, so that's going to work with that. Yeah. Right, so after the fact, that will work mathematically. I can make that work there. If I pre-assume a lot of stuff, yeah, I can make that work there. But I have to use a sub point. Right? I have to use a sub point, an azimuth, flat planes. I must use an angle. All these things, I must use angles, azimuths, flat planes, and sub points. I must use, which is actually, this is the real sub point, just so you know. But the point is that I have to show the borders, these things. A flat earther has to show them. Yet they have the neck to talk down to us. They have the neck to get in our way. These people who don't know anything about anything. They're idiots. They're bozos. They have no business even speaking to us. A lot of time they have no even business speaking to us. Because all they are is in our way. We need to stop addressing these people. Push them out of your way. Go away. We don't need your globe. Ye need us. You need our flat plane. We don't need your globe. We don't need ye. End of story. Thanks for watching. I know it was a bit extended.